Hello, this is my homework for lesson number 20 for Paul McWhorter's Raspberry Pi Pico solution to the temperature control, the temperature sensor. It's been a while since I've been doing this programming. I've been with family and on several different outings. I'm happy to be back. This one here, my solution basically came from Kevin's example. His was the best, and I also saw where Keith Lohmeyer copied this method as well. When first running this, I had an error message that I pinpointed that it came from the sensor itself, and of course that timer delay in there is what worked the best. And wiring my Pico up, of course, the third pin over is the ground, so it goes to the blue rail, and the fifth pin goes to 3.3 volt goes to the red rail. The red rail comes over here to the sensor. There's my red wire. The third line comes over, goes down to the ground, and then the data comes over to pin 16. I hook the buttons up to the ground with this line here, and then this other line comes over to pin 18. I really like these buttons. These are great big covers, so they're easy to find, and it's going to take a little while to get used to them. In my coding, of course, it's just the way we've set it up before with importing the pin and the time and then the DHT11. I set my pins up with 16 and 18, setting the variables up this way. myPin sister, sensor, button state, and units equals true. Here is the timer, so that it actually can catch up to reading those items. Then, of course, I print my header, sensor settings. In my loop, I set the toggle variable over here, and then these two here go to set the value of that. And then, of course, I prime the sensor for a measure, and then set that value, these two values, from the sensor into this variable and this variable. I've always had a trouble figuring how to turn the toggle switch on and off, so I just copied the example as best I could from Kevin's video. If the button state is greater than the previous button state, then of course we're setting the units to the opposite. So if the units are true, then of course I print here with a /R and all those items, which is coming out to this one here. And if it's not true, then it has to be false. So then I calculate the value of the Fahrenheit frequency with this formula here, and then I print out those items here, and they come out like this. Now what I found is when, of course, I push my button, I actually have to hold it down till it goes through at least a cycle, and then it actually affects itself on a release. So I just suppose that's the way that this microcontroller works. I just have to be patient with how it works. So there is my toggle. So now I'm reading centigrades. Here in Utah, of course, the humidity is a lot drier, and I'm in my house, so that's one reason it's at 50. And in the house, of course, it's might be hot outside, but it's a constant 73 degrees inside. And there's my homework for this week. Thank you.